Hello everyone. So far we have studied multiple concepts associated with semiconductor physics and semiconductor devices as well. And we are now at a stage where we have enough knowledge to also see some of the experimental demonstration associated with similar concepts. We already have gone through some of the experimental demonstration. At least we already have seen different instruments, some of the experiments, what are the different types of instruments that one can use for electrical characterization, what are the different types of instruments that one can use for semiconductor devices or sensors. And in this direction, we also have seen some basic experiments, some demonstration of the devices. Today, we will again do an experiment which is related to another optoelectronic device which is known as solar cell. I think you all have seen in solar cell a solar panel at your home or in various other places, which looks like a black colored big panel and it has silver color lines. So basically these are electrodes, and the black colored material that you see, these are there is semiconductor material like silicon if it is in silicon solar cell, and then it has a coating and other things for packaging. So the material inside which is responsible for this voltage generation is basically silicon if it is in silicon solar cell. One can make solar cell with other materials also. However, one thing that we should note, that the purpose of a solar cell is to generate power, and there are multiple research or multiple efforts going on how we can increase the efficiency of one solar cell. When I say efficiency, what I mean is when light falls on this solar cell, there is a power associated with that light. Now, how much of that power is getting converted to electrical energy is what known as efficiency. For example, if you illuminate the solar cell with say 1000 watt of light, equivalent power of that light is say 1000 watt. Can I get 1000 watt power out of this solar cell at present? No, there is some loss. We possibly will get say 150 watt, 200 watt, so on and so forth. But the applied energy was, or applied power was 1000 watt. So people try to increase that, whether we can get maximum power out of this solar cell or not. However, today I will demonstrate the experiment associated with solar cell for two different purposes. The first purpose is to show you how we can characterize a solar cell just by shining a light, how much voltage we are getting, and secondly, what is the other application of a solar cell, meaning these are not traditional application of course. So if somebody wants, someone can also use a solar cell as a light sensor, because based on the light intensity, your voltage coming out of this solar cell will change. So you can also use a solar cell as a light sensor. But definitely this solar cell or any solar cell is not fabricated to work as a light sensor. It also senses light is something that one can also take advantage of. At the same time, I will also show you that there are instruments, because when you characterize a solar cell, you need to ensure that the solar cell is illuminated with a standard solar light. So you can't just go outside with your fabricated solar cell to characterize it. Even if you go outside, for example today, the intensity of light coming out of solar, coming out of sun, the solar illumination that you have outside at the moment probably is very different from a standard point standard value. Why? Maybe today the sky is cloudy, or this may also happen that in your place today the light intensity is different from some other place. So, the characterization will not be kind of reference characterization. It is not a standard characterization because you do not have a standard environment. And secondly, it is very unfeasible that you every time make a solar cell go outside and then do the experiment. Many a times it is not possible because you may fabricate those devices in a closed environment like clean room or in a very regulated environment, and then you can't take all instruments outside your lab just to characterize the solar cell. And the second problem, as I have mentioned, you can't standardize the light that is coming out of sun, say today at this moment. The intensity of the light may vary after 10 minutes, after 1 hour, depending on what is the condition or the weather, right. So, for that purpose, people developed solar simulator. I also have shown you the solar simulator. So, we have seen how it looks and how we can actually generate a solar intensity. So, there are different standardization of solar illumination. For example, AM 1.5 is one of the standards. Again, this particular device or the details of this device, the working of this device is not a part of this course. Basically, it is again an optoelectronic device. So, as I have mentioned before also, or if there is a scope that if I offer an course on optoelectronics, then I will definitely discuss this in details. But for the time being, I just want to show you that a solar cell can also be used as a light sensor if needed. Sometimes maybe you are fabricating a solar cell and somehow it is not working well in terms of solar cell, because there are multiple figure of merits and probably they are not fitting well into that figure of merits. You can think of making an light sensor with that developed solar cell just by changing the geometry or incorporating some new innovation into it. That may become a very good light sensor, by the way. So, just to give you an idea, and this experimental exposure will give you the idea how we can characterize, say, photodetector or solar cell or any optoelectronic devices where you can illuminate the device with a certain wavelength of light or say solar illumination. So, let us go back to the lab and let us see how we can actually do that experiment. So, the topic of today's discussion is photovoltaic experiment, because the phenomena associated with solar cell is photovoltaic effect, where the photons or the light actually gets converted to an voltage, and we will see that happening during the experiment. I will also show you the experiment where we can illuminate the solar cell with, say, a standard solar illumination using a solar simulator, and we will see the voltage that we are getting from that solar cell. So, let us go to the lab and do that experiment. Let us do an experiment with a solar cell and let us try to understand that how we can use the solar cell also as an sensor. So, we all know that a solar cell, usually a silicon solar cell, looks like this. It is a very small panel and there are 2 electrodes. So, this is a commercial solar cell and you can see at the back side the electrodes are given, and this particular solar cell will generate voltage when you shine light on top of it, or when you put this solar cell under solar irradiation, meaning under sunlight, you will get a voltage output from this solar cell. So, we can also use this particular solar cell as a sensor, as a light sensor, because anyways this is light responsive and you get a voltage in presence of light, or when you change the intensity of light, the voltage output also will vary. Higher the light intensity, higher will be the voltage. That is how this solar cell output works. This is also a semiconductor device. because it's silicon based solar cell. You can make a solar cell with many other materials also. This could be an organic solar cell which is fabricated using organic materials. We do some experiments in the lab where we develop the solar cell with organic materials, with some other inorganic materials, and also with some different kind of polymers. The idea is whether we can make flexible solar cells or not, or whether we can make a solar cell which has an higher efficiency than what we have with silicon solar cell now. So these are some of the questions that usually we try to address in the research level. Apart from that, we also can try making different photo detectors using the same phenomena. If we have an photovoltaics associated with some material or some device, we can actually use that particular device for photo sensor. So that also will become a semiconductor based device. Now let us do a very basic characterization of this solar cell using the multimeter. So I already have mentioned that the multimeter shown over here will detect voltage from any sort of sources. Now when we have a solar cell which works, which is basically a photovoltaic phenomena or outcome of an photovoltaic phenomena, you will get voltage as output from these two terminals, and when you shine light on top of this solar cell. So this works as a source and you can detect the output using these two terminals. So what we will do is, we have two terminals also in this multimeter. We will connect this solar cell with this multimeter. Let me keep it here, and then we will go to this software where we have selected this DMM, that is digital multimeter, and this is the settings of the DMM. So we want DC voltage, the range is auto, and other different parameters are kept as it should be. We will go to the graph and we will run this app, meaning we are running this experiment, and you can see that you are getting some voltage which is close to 2.16 in this ambient light condition. We have LED panels over this, LED lights in this particular room. So this particular solar cell is now under this LED light illumination, and you get certain voltage in the response. So you can see, if I create a shadow on top of this solar cell, you get a dip here in the voltage, right? Again, when I remove my hand, it goes back to the value that it used to show before, for example around 2.2 volt or so. I can also cover this with my hand and the voltage will drop drastically. Now it is close to 800 millivolt, you can see over here, and the moment I remove my hand from the top of this solar cell, the voltage is again coming back to around 2.2 volts, right? One more thing that we can notice in this case is, let us change the polarity of the multimeter, meaning the red one was connected in the left electrode, the black one was connected in the right electrode, meaning this right side is basically negative and the left side is basically positive, and that is why you used to get a positive voltage. Now I am changing it. I am connecting the red terminal in the right electrode and black terminal in the left electrode. For the same solar cell, now you can see here you are getting a voltage which is minus 2 volt or minus 2.2, close to minus 2.2, which means whatever voltage we are getting, it has a constant terminal, constant polarity. The moment we changed the polarity of this multimeter, we are getting exactly opposite value. Again, if you make a shadow on top of this solar cell, you can see that the value has now basically decreased. Visually you may see that it has increased, but you can see it's a negative potential, it's minus. So magnitude wise it's basically less, it's now minus 1.1, and without shadow it is basically minus 2.2, close to minus 2.2. So this experiment also shows that a solar cell can also be used as an sensor if needed, but the purpose of a solar cell is to generate voltage so that you can use this particular device for energy harvesting. We will do one more experiment with this solar cell in the solar simulator. We already have discussed what is a solar simulator. Now let us do the experiment in the solar simulator. So we will now do the solar cell experiment in this solar simulator. We already have discussed what is this solar simulator, and we know that there is a light on top here, and this will create light illumination or irradiation back here in this down here in this particular area, right? And we can control this particular instrument, especially the light part, using this software. So we have set this arrangement already, and we are now trying to create AM 1.5, which is a typical simulation of the solar condition outside in the environment, which is the standard one. And when we start the illumination here, you can see I have started the illumination here in the software, and you will get, this is the total irradiation, the value also is given over here, and you will get the irradiation in the device. You can see that there is a solar irradiation which is similar to the one that we get outside, the standard one. For different condition, if the condition is cloudy and etc., then probably the irradiation is different, but this is how we do a solar replica of the situation that we get in the environment in an instrument, so that we can characterize different devices. And you can see the solar cell is kept here and connected to the multimeter, and the value is again around 2.2 volts, which we already have seen in the ambient light, meaning in this particular room we have LED lights on top in the panel. So you get an 2.2 volt from this particular solar cell. Now what we will do is, we will put this particular device under this illumination here, and let us close this. Now in such a situation you get a voltage which is close to 5.7 or 5.8. So this particular voltage we get at AM 1.5, and this is positive value, meaning the positive terminal, that is the red one of the multimeter, is connected to the positive terminal of the solar cell. The negative terminal, that is the black one, is connected to the negative terminal of the solar cell. You can again take it out from this instrument to the ambient light, and you can see the value is again close to 2.2. The moment I create a shadow, it decreases, and if I remove my hand, it goes back to around 2.1 or 2.2. So this is again in characterization, typical characterization of a solar cell, which is basically a semiconductor device. We also have seen how we can actually use this particular device as a sensor, because this basically is responsive to light, so you can use it as a light sensor or photo detector. Nevertheless, solar cell is not meant for using as a sensor. Rather, this is an energy harvesting device. You get a energy from this particular device when you put this under light illumination. So we just have seen how we can connect the solar cell with different instruments, including solar simulator. So we do not connect solar simulator directly with the solar cell, because the purpose of solar simulator is to illuminate a certain standard light, and we keep the solar cell below that light illumination in order to characterize. And we also have seen that if we change the polarity, we are getting the same value of voltage, but with opposite polarity. For example, if it is giving 2.2 volts, if you change the polarity of the say voltmeter, you will get minus 2.2 volt. So, that minus symbol comes because of this change in polarity. So, the positive side of the solar cell is connected to the negative side of the multimeter, and that is why you get an negative voltage. So, you may come across similar situations when you do experiments with solar cell. So, that is just to show you that even if you get negative voltage, you can always check the polarity of the device. And we also have seen in solar simulator, when you generate this solar illumination, equivalent to solar illumination, and then you what is the value that you get. So, that is how you can characterize a solar cell or any photo detector also. We also have seen that if you create a shadow on top, then the voltage value decreases, which gives us an idea that this can also be used as a light sensor if needed. So, these are some of the aspects that may be very useful for you when you go through the different experimental conditions, and when you do some research on different devices, or when you do some experiments also with some devices. So, we will conclude this experimental session today. We will study more concepts related to semiconductor device and physics and semiconductor sensors in the coming lectures. Till then, thank you.